So in the last episode, we discussed about inverse of sine function. And in this episode, you will learn about the inverse of other trigonometric functions. So let's begin with cosine function. And now, to draw the graph of inverse of cosine function, first we shall draw the graph of cosine function. And the graph of inverse of cosine function can be obtained by interchanging the x and y axis. Now we shall draw the graph of y is equal to cos theta. Now here again we have angles on the x-axis, and on the y-axis we have got the corresponding values of cos theta. Just like other trigonometric function, cosine function is also a periodic function with a period of 2 pi. And also, if we restrict the domain of cos function to the interval 0 to pi and the range to 1 to minus 1, then it is a bijective function and therefore it is invertible. An invertible cosine function is defined as the function f from 0 to pi to the range minus 1 to 1 such that f of theta is equal to cos theta. And in the interval 0 to pi it is bijective and therefore invertible. And now since this is invertible, so let's find the inverse of the cos function. And now to draw the graph of inverse of cos function, we interchange the x and y axis. And here we have the graph of inverse of cosine function. Here on x axis we have got the values, and on the y axis we have got the corresponding angles. And the domain of inverse of cosine function is equal to minus 1 to 1. And the range of inverse of cosine function is equal to 0 to pi. And now let's learn about the graph of inverse of tangent function. And for that, first let's draw the graph of y is equal to tan theta. And the function y is equal to tan theta is defined as the function f from the open interval minus half pi to half pi to the range set of all real number such that f of theta is equal to tan theta. And in the open interval minus half pi to half pi, the given function is also bijective and therefore it is also invertible. Also remember, this is an open interval and the endpoints minus half pi and half pi are not included in the domain. And now to obtain the graph of y is equal to tan inverse x, we shall interchange the x and y axis. So here you can see, and the graph obtained is shown in the screen, and the function y is equal to tan inverse x is defined as the function f from the set of real number to the open interval minus half pi to half pi such that f of x is equal to tan inverse x. And now we shall draw the graph of inverse of secant function. And again, to draw the graph of inverse of secant theta, first we shall draw the graph of y is equal to secant theta. Also, from the graph, you will observe that the secant function is defined in the interval 0 to pi except at half pi, and its range is from minus infinity to minus 1 and from 1 to infinity. And in the interval 0 to pi except at half pi, the function secant theta is bijective and therefore it is also invertible. And because it is invertible in this interval, so we can also find its inverse in the given interval. And again, to draw the graph of y is equal to secant inverse x, we interchange the x and y axis in the graph of y is equal to secant theta. And for the secant inverse function, its domain is from minus infinity to minus 1 and from 1 to infinity, and the range is from 0 to pi except at half pi. Now let's draw the graph of inverse of cosecant function. And just like in case of other trigonometric functions, first draw the graph of y is equal to cosecant theta. And also remember, the function cosecant theta is defined in the interval minus half pi to half pi except at 0, and it has a range from minus infinity to minus 1 and from 1 to infinity. And in the interval minus half pi to half pi, it is also bijective and therefore it is invertible. And because it is invertible, we can also find its inverse. So now let's draw the graph of inverse of cosecant theta. And the graph of inverse of cosecant theta can be obtained by interchanging the x and y axis. And the domain of the cosecant inverse function is minus infinity to minus 1 and from 1 to infinity. And its range is from minus half pi to half pi except at 0. And now we shall draw the graph of inverse of cotangent function. So let's first draw the graph of y is equal to cot theta. And note that the domain of cot function is in the open interval 0 to pi, and its range is the set of all real numbers. And also in the interval 0 to pi, it is a bijection. And as it is a bijection in this interval, so that means it is also invertible. So we can find its inverse in the given interval. So now let's draw the graph of y is equal to cot inverse x. And just like in case of other trigonometric functions, we can draw the graph of cot inverse x by interchanging the x and y axis in the graph of y is equal to cot theta. And the domain of cot inverse function is the set of all real numbers. And its range is the open interval 0 to pi.